Hi, welcome back to Synthetic Biology 1. Today we're going to be preparing competent cells. So how I like to start is by preparing my solutions. So we have two solutions that we need to prepare. One is a 100 millimolar solution of calcium chloride, and another one is 100 millimolar calcium chloride with 15% glycerol. So we'll need 1.5 grams of calcium chloride 2 times. All right, and let's not forget to label our solutions. So this guy is going to be our 100 millimolar calcium chloride. And over here, 100 millimolar calcium chloride with 15% glycerol. Okay, so I'll label these, and I'm being careful to label these bottles near the top because we're going to put them on ice. And if the labels get wet, they can fall off. Okay, so now I'm going to take my water, and I'll go ahead and add it to the calcium chloride solution, bringing the total volume of the solution up to 100 milliliters. Pour that in, top it off at 100 milliliters. I'm also going to add some water to the calcium chloride solution, but I'm not going to add the full 100 milliliters yet. I'm just going to take it up to 50 mils so that there's room left over for adding the glycerol. Okay, so now let's pipette the glycerol. I need 15 mils of glycerol. And for this, I'm using 100% glycerol solution, and it can be really a pain to pipette, so I'll have to be extra careful. One tip here is just put the tip of the pipette into the glycerol, because otherwise the entire pipette will be coated with glycerol. To be a little patient to get exactly the right level. Let the excess glycerol drip off. And now this is why I added some water to the solution, because when I add the glycerol, I want to pipette up and down just to wash the excess glycerol from the pipette tip. Okay, cool. And now we'll take the water and just top off the solution, bringing the total volume up to 100 mils. You can tell I'm not being too careful with my measurements for these solutions, and that's okay. I don't need to be. They're quite forgiving, and close is good enough. Okay, there's my two solutions prepared. Mix them up, and I'll store these on ice. So you want to store them on ice. So the most important thing about preparing competent cells is that once we've resuspended the cells in the calcium chloride solution, we want to keep them always, ever after, at 4 degrees Celsius, because if we allow the temperature to come back up, the cells might start to lyse. Okay, so that's our solutions. Now we're going to go ahead and start the culture of cells that we're going to actually be making competent. So for this, I have a plate of Mg1655. You might want to use NEB Turbo or DH5 alpha or some other cloning strain. This is just a wild type strain of E. coli, and it's what I happen to have ready around the lab. Okay, so we're going to start a 5 ml culture of E. coli in LB media. So these are 14 ml Falcon tubes. Don't forget to label. Okay, there's my 5 mils, and now I am going to take an inoculation loop and pick just a single colony of E. coli from my plate to start my culture with. It's important when you make competent cells to always start from a single colony of E. coli, because that way you know that the cells are genetically homogeneous and not contaminated. Okay, so now I'm going to pop this in the incubator and grow it at 37 degrees with shaking overnight, 8 to 12 hours. Okay, so it's 8 to 12 hours later, and my culture of E. coli is nicely saturated. So the next morning, when you're ready to prepare your competent cells, when you come in, what you do is you'll take these cells and we're going to dilute them by a factor of 200 into a fresh 50 ml culture. So we always want to make competent cells using freshly growing log phase E. coli because they're the healthiest and they'll be the most competent. Okay. So for my 50 ml culture, I'm using a 250 ml flask. It's important to use a much larger flask than the volume of cells that you're growing so that the cells are nicely mixed and well aerated so they can grow quickly. Now to my 50 ml of LB media, I'm adding 250 microliters of my saturated E. coli solution. Okay. Mix that around. So we'll grow that in the incubator at 37 degrees for 2 or 3 hours until the OD reaches 0.5 or 0.6, which indicates that the cells are in the mid-log phase and ready to become competent. It's 2 or 3 hours later, and I've collected my cells from the incubator, and they're at an OD of exactly 0.5. And so they are ready to go for the next step of the competent cell protocol. So I'm going to take my my culture of E. coli, my freshly log phase E. coli, and I'll add it to a 50 ml Falcon tube like this. Okay. And then put it in the centrifuge and spin it down at maximum speed for 10 minutes to produce the pellet of cells for the next step in the protocol. Okay, so now we've collected our pelleted cells. Let's turn them into competent cells by adding calcium chloride solution. So the first thing that I'm going to do is very quickly pour off the supernatant from the centrifugation. Store these cells immediately on ice. So from now on, everything that touches these cells should be at 4 degrees Celsius or colder. Now, we're going to resuspend these cells in our calcium chloride solution here, 15 mils. Okay. So I'll resuspend the cells by pipetting up and down. The pellet should come apart pretty easily after a few rounds of pipetting, giving us a nice uniform resuspension of cells. We don't want to spend too long doing this, or the cells will start to warm up. Okay. Now I'm going to leave these cells on ice for at least 4 hours, or it could be longer, even overnight. Okay, so after the second round of centrifugation, we will treat the cells the same as before, except now we are going to resuspend them in 4 mils of the calcium chloride glycerol solution. So I'll go ahead and pour off the waste. And resuspend in 4 mils of calcium chloride glycerol. Okay, so now these cells are ready to use. They're ready to transform or to store, however you want. For the final step, I'm going to aliquot this large culture of cells into smaller Eppendorf tubes that will be more convenient to transform. So for that, I am going to need even more ice. I'm using this aluminum rack to cool the cells, so this will transmit the heat very rapidly from the tubes to the ice and keep everything nice and cold. So I like to aliquot into these 1.5 mil Eppendorf tubes. And I usually do 200 microliter aliquots. So a typical transformation will use 20 microliters of cells. So 200 microliter aliquots is sufficient for 10 transformations from one tube. Okay, so these competent cells are finished. They're ready to use immediately, or they can be stored at -80 indefinitely.